Okay, so for this problem, okay, we're gonna write the requested portions of a class called baseball player. It contains the following data instances. And note that this problem has 3 parts. And I'm actually going to record this commentary after the fact because I already recorded this video and for some reason my audio didn't go through. And the instances, the fields that the class baseball player needs to have are string name, string position, its number at bats, and blah blah blah. So I'm going to delete that stuff that I did for the previous problem for month, and we're just going to follow the instructions. So public class baseball player, and that's a header of the class, and my closing brace, and we just start typing what it tells us there: string name, string position, int num at bats. So now we have a bunch of ints, right? So actually what I'm going to do here in just 1 second is, when we have a sequence of a bunch of ints, we don't need to have a new line for each one. We don't have to have int num at bats, semicolon, int num single, semicolon, int num double, semicolon. We don't have to have that. We just have int once, and then we have all the ints we're going to declare, separated by a comma. Num at bats, comma, num singles, comma, num doubles, comma, num triples, comma, num home runs. And then we have our semicolon. So, you know, in Java you can actually use shorthand declaration for that. And the first 2 lines actually could have been string name, comma, position, semicolon, because they were both strings. Alright, so that's one little shortcut that some of the more advanced people in the class could start using. And one disadvantage that it does have is that it makes it more difficult to find, like that num singles, for example. Here I'm demonstrating how, you know, that one is equivalent to the other. This statement that I wrote is equivalent to writing int num at bat, semicolon, int num single, semicolon, int num double, semicolon, blah blah blah. And the last thing we're going to declare is double batting average. But what I was going to say is that some of the more advanced people in the class can actually go ahead and start using this, and the disadvantage that it has is that sometimes it makes it hard to remember that you actually declare the variable there, because it's harder to see it. Okay, so we're done with part A. That was 7 points, and we're tackling part B already. You know, it is a 3-point problem, so if you get one part right out of it is 7 points, and those first 1, 2, 3, 4, 5 lines of code would have given you 7 points. And I just realized now that the baseball player was misspelled. And now all we've done really is type the constructor. What is a constructor? A method which has the same name as a class and no return type. That is what a constructor is, and it helps us teach Java how to build new objects of our class. So we have public baseball player. It takes the 2 parameters that it tells us that we should take, which is the player's names and position. You can see in part B right there. And it sets them to, it uses those 2 parameters to set values to the fields that we have in the baseball player class. So that is very simple. Now we're going to go to part C, which is write a method that computes the player's batting average, which is the total number of hits. So we have to add all those different kinds of hits up and then divide by the num at bats. And we note that it says returns the number of returns the player's batting average. So this method is going to have a return type, and it's going to be a double return type, because, you know, batting average is like 0.505. You know, the convention for batting average is that it's just a 3-digit decimal number. And not that I would expect any of you nerds to know that, but that's how it works in baseball. So we have our method public void compute batting average, and oh no, actually, you know what? Now I just remember that it's not a, it doesn't return anything. It's a void, and the reason why is we have a field for the batting average, right? So we need to do is just set that field to the correct value. And in order to avoid the error, which the problem tells us to avoid, we have to have that little if statement there we just wrote. So if the number of times that bat is equal to 0, your just batting average is just 0, and that's it. You know, because if your number of bats is 0, then your hits are obviously 0. And if you tell Java to divide 0 by 0, it's gonna flip out on you. And now let's see what the next thing I'm gonna do is. Okay, I'm handling the exception where, you know, there might be a programmer error that generates some sort of number of bats which is negative, or maybe it's not initialized or whatnot. Else, so if number of bats is not less than or equal to 0, we just do batting average equals all the different kinds of hits added up together, num singles, num doubles, num triples, num home runs, plus num triples, plus num home runs, yeah, and I continued over in the next line because Java does ignore white space. Divided by num at bats. I changed my mind about continuing on the next line. And that is it for this problem. That gets you full credit, the whole 14 points. It's worthy of noting that those two little lines in the middle with the constructor were actually worth another 7 points. Okay, so I'm going to test it on NetBeans to make sure it compiles. Pasted it and it does compile. That's it. That's all you need to do for that problem. And that's my little YouTube upload window. So now I'm going to go back to the test. Consider the car class whose incomplete definition is shown below. So we have a public class car, and this is actually pretty hard to read in this HTML format, but in your screen it looked fine. I know I saw some of you while taking the test. So, you know, we have to ignore all the Java doc stuff, and the first line of code that we see that's meaningful is a public car. Double miles per gal, double miles, double gas tank holes, and double gas tank gas. That's our constructor, and it basically, you know, takes those 4 parameters and sets 4 fields. So you know, that's all our car cares about is the mileage and how much gas is left, how much gas is possible to have in the tank, and how many miles it has, and what MPG it can get. So then we see public void and drive, and public void get mileage, get gas in tank, and there at the end we see the field that we have: private double MPG, private double mileage, private double tank capacity, private double gas in tank. And they ask us to write the method find gas used. This method should calculate and return the amount of gas used in driving num miles. Assume that you have enough gas to make the requested trip. So basically we're just going to write a little method that finds the gas used in driving a number of miles, and naturally, you know, when you're driving a certain number of miles, and first of all, you know, notice that this method only asks you to compute to write a method. This problem only asks you to write a method, not a whole class. So we just use the method header that they gave us: public double find gas used in num miles. And what are we going to do in order to find the amount of gas used in driving an amount of miles? What do we need to do? You know, miles is in miles, and we have a field in our class which is MPG, which is miles over gallon. So if we just go back to chemistry dimensional analysis, we take the miles and we divide it by the MPG. You know, the miles cancel out, the gallons comes out to the numerator. So all we gotta do is divide num miles by MPG, which is a field in our class. So our class knows what it is, and we're done. That is 10 points, because this is a 2-part question, so that would be 10 points for this question. Now, we need to write public double drive. and double num miles. So we just use the header that they gave us, or public void, sorry, drive, double num miles. Okay, and what drive is gonna do is simply gonna update fields. Look, it says write the method drive. The method drive is given a number of miles. The car has traveled as a parameter. Certain private instance variables need to be updated as a result of this action. You may include a call to find gas use from part A. Assume this function works as specified regardless of what you wrote for part A, and use a method header to write your method drive. So, we're just going to follow instructions. And what we need to do, let's look at the fields that we have. We have MPG, that never changes, that's immutable. Your car's MPG is your car's MPG. We don't need to worry about updating that. We have private double mileage, which, when we drive, we need to increase the mileage. So that's one thing that we're going to update. Then we have a private double tank capacity, another thing that's fixed. It doesn't change ever for your car. Your car's tank doesn't get bigger or smaller. And finally, we have private double gas in tank. As we drive, that goes down, depending on the amount of miles we drove. So that's the other thing that we need to update. So we're going to write this method, and it's going to update mileage and gas in tank. And that is it. And we just need to consider two scenarios. When the amount of miles that we want to drive is greater than the amount of miles we could drive based on the gas that we have in the tank previously, we just need to say that we ran out of gas, and we drove the amount of miles that it took until we ran out of gas, and we used the amount of gallons that it took until we ran out of gas. So what we're going to do first is create this variable gallons, and what we're going to put in it is find gas used. We're going to use our previous method, find gas used, in driving this number of miles. And we're going to call that gallons. So gallons is the amount of gas that it takes to drive the amount of miles that this method wants to drive in this car, right? So if gallons greater than gas in tank, meaning that the amount of gallons of gas that it took to drive this amount of miles is greater than the gas that we had. We just say gas in tank can go 0, so we basically run out of gas, and we do else gas in tank minus equal gallons, meaning that we reduce gas in tank by the amount of gallons that it took to drive this amount of miles. So we're partially done there, and what we're going to do now is make these if statements compound, so that we can modify the mileage and the gas in the tank in one shot. So if gallons greater than gas in tank, that means that we drove essentially until we ran out of gas. So our gas in tank is just going to be 0, and the mileage is going to go down by the amount of miles that we drove until we ran out of gas, which is not necessarily the same as the num miles which got passed into the problem. So we're just going to multiply the MPG, so miles over gallon, times gallon. The gallons cancel out, dimensional analysis, and you get the number of miles. So gallons is the number of gallons of gas until you run out of gas. You multiply that times MPG, and you get the number of miles you drove until you ran out of gas. And that's all you need to do. The odometer by as many miles as we drove until we ran out of gas. Okay? And how do we do that? We had a gas in tank. We have a mileage variable. Yep. Mileage equals gas in tank times MPG. That's the amount of miles we drove before we ran out of gas. Gas in tank is in gallons. Miles per MPG is in miles over gallons, so the gallons cancel out, and you know that the result you get is miles. So mileage is plus equal this. So we increment mileage by that, and else gas in tank. And we're gonna cover the other case here. So gas in tank minus equal gallons, and let's do the mileage first. Nah, we can do the mileage after. Mileage plus equals gallons times MPG, and we are done. And that is it for this problem. So I'm gonna copy it. I'm gonna paste it on NetBeans. And I'm gonna do, actually, whatever. I'm gonna create the class car and just stick these methods in here. I'm gonna type the fields. I'm gonna paste this first, and then I gotta type the fields. 1 second. Tab this out, and I'm gonna type the fields to make sure it compiles. So private double mpg, private double gas in tank, private double we have, oh, there's a typo here, gallons, mileage, is it mileage that it's called, or double mileage, tank capacity are the ones that are missing, mileage and private double tank capacity. And you know, that's all I need to make sure that this compiles, and it does. You know, we're not actually gonna run it, so just need to make sure that our code was right, and it is. And that is it for problems 6 and 7.